Imagine a world where your electricity bill is not just trimmed, but slashed by more than half. A world where the phrase rolling blackout is a relic of the past, and energy insecurity is as outdated as dial-up internet. Now, picture that world powered not by forests of steel giants spinning on distant horizons, nor by endless seas of glinting solar panels, but by a strange, ground-hugging contraption, something that looks more like a high-speed racetrack than any power plant you have ever seen. Could this be the future of American and even global energy? Or is it just another wild idea, destined to fizzle out like so many energy startups before it? Let's rewind the tape for a moment. For nearly a century, the American power grid has been a battleground, where the old guard, coal, oil, and natural gas have faced off against a rising tide of renewables. Wind energy, in particular, has surged from obscurity to stardom. In the wind-swept plains of Wyoming, for example, wind turbines now generate nearly 1/4 more precisely, over 22 out of every 100 units of the state's electricity. Nationally, wind has become the largest source of new power generation in recent years. But there's a catch. The conventional wind turbine, that iconic pinwheel perched atop a steel tower hundreds of feet tall, comes with baggage. These machines are massive, often taller than the Statue of Liberty, and their three-bladed rotors sweep out circles the diameter of a football field. Their size makes them expensive to build, transport, and maintain. Giant cranes, fleets of tractor-trailers, and convoys of workers are needed for every installation. And the visual impact? Unmistakable. Many communities fight fiercely against new wind farms, citing ruined views, noise, and impact on wildlife. Local opposition has stopped projects in their tracks, from New England to California. The result? The explosive growth of wind energy is stalling. In the past decade, the pace of new wind projects in the United States has hit its lowest point, with many planned installations scrapped or delayed. The price tag for wind power, while dropping over the years, remains a hurdle in areas with challenging terrain, strict height restrictions, or fragile supply chains. Enter Airloom Energy, a Wyoming-based startup with a plan so radical it is turning heads from Silicon Valley to the Pentagon. Rather than simply tweaking the existing design, Airloom's engineers have thrown out the old playbook. Their prototype ditches the classic spinning tower. Instead, it features multiple aerodynamic wings, resembling airplane wings, zipping around an elongated oval track just 60 feet above the ground. That's less than half the height of a typical wind turbine, and shorter than many streetlights. So what's the big idea? By keeping things close to the ground, Airloom hopes to dodge many of the headaches that plague conventional wind farms. The system is lighter, by as much as 90% compared to traditional turbines, because it uses smaller, mass-producible parts. No more shipping gargantuan blades or assembling sky-high towers. The company claims it can deploy a full-scale wind farm in less than 12 months, compared to the 2 or even 3 years needed for conventional projects. And because the structure hugs the ground, it can be installed in places where tall towers are banned, near airports, military bases, or scenic areas where preserving the view is non-negotiable. The stakes are enormous. Airloom is aiming for a levelized cost of electricity, meaning the average cost over the plant's entire lifetime of less than $45 per megawatt-hour within 3 years. And by the end of this decade, the goal is to push that price under $10 per megawatt-hour. To put that in perspective, the average cost of electricity from new coal or natural gas plants in the United States is currently more than twice that amount, sometimes even 3 times as much. If Airloom hits its targets, it would rewrite the rules of global energy markets. This vision has attracted some of the world's most influential backers. Breakthrough Energy Ventures, a clean tech investment fund founded by Bill Gates, has led multiple rounds of funding, joined by Lower Carbon Capital, MCJ Collective, and others. Together, these groups have poured tens of millions of dollars into Airloom's research and development. Even the U.S. Department of Defense has gotten on board, awarding the company a contract worth over $1 million to explore military applications for remote bases and field operations where reliable power is a matter of national security. The state of Wyoming, eager to diversify its energy economy, has invested $5 million through its Energy Matching Funds program. But for every cheerleader, there is a skeptic. Industry veterans remember the wind power busts of the 1980s and 90s, when dozens of startups promised to revolutionize the industry, only to be sunk by technical problems, cost overruns, or plain old physics. Michael Barnard, a leading renewable energy analyst, warns that radical design changes often hide old problems. He points out that wind speed drops closer to the ground and asks whether Airloom's low-profile wings can truly capture enough energy to compete with turbines perched hundreds of feet in the air. You can't cheat the laws of physics just by moving the blades, Barnard cautions, echoing the concerns of many engineers who have seen promising prototypes fail in the real world. There are other technical challenges as well. Wyoming's notorious weather, fierce blizzards, sudden lightning storms, and gusts that can topple steel towers will test the durability of Airloom's lightweight structure. Maintaining moving parts at ground level poses a different set of risks and maintenance headaches. Regulatory hurdles remain too. Every new design must pass rigorous safety and environmental assessments before it can be deployed at scale. Yet, the potential upside is staggering. If Airloom's pilot in Wyoming succeeds, it could trigger a seismic shift in the renewable energy landscape, not just the United States but around the world. Imagine wind farms sprouting up in places once considered impossible: mountain valleys, rugged coastlines, even dense urban areas hemmed in by zoning laws and sky-high real estate prices. Remote islands, deserts, and communities cut off from major transmission lines could generate their own cheap, reliable power. Military installations, data centers, and industrial parks could install modular wind systems in months, not years. Faster deployment means more flexible responses to changing energy demands. Think about it. In the aftermath of hurricanes, wildfires, or other disasters, emergency crews could install Airloom systems to restore power rapidly. In developing countries, where access to reliable electricity remains a barrier to economic growth, smaller, easy-to-assemble wind farms could leapfrog traditional grid infrastructure entirely, much like mobile phones did for telecommunications. This new approach could also change the economics of energy storage and integration with other renewables. Airloom's rectangular swept area, rather than the classic circular pattern, makes it easier to pair wind with solar panels or batteries on the same plot of land, maximizing output and efficiency. The company claims its turbines can be co-located with existing agricultural, industrial, or transportation uses, minimizing the land footprint and reducing conflicts over land use. Let's look closer at the numbers. With mass manufacturing, Airloom's design could drive costs down dramatically. The company projects that, by scaling up production and streamlining installation, the price per megawatt-hour could drop to levels previously thought impossible. If they achieve their target of under $10 per megawatt-hour by the early years of the next decade, wind power would become the cheapest form of electricity in history, cheaper than coal, oil, natural gas, or even most forms of solar. This would have profound implications for everything from electric vehicles to digital infrastructure, making green energy the default choice for new investments. If you are wondering how this could affect your everyday life, the answer is, in more ways than you think. For one, lower electricity costs ripple through the entire economy. Homeowners and renters alike would see their power bills shrink, freeing up cash for other needs. Businesses could invest more in innovation, expansion, or employee wages. Industries that depend on energy, manufacturing, data centers, transportation could become more competitive against rivals abroad. Even public services like hospitals, schools, and transit systems would benefit from more affordable, reliable power. The benefits extend beyond economics. With less reliance on fossil fuels, communities would enjoy cleaner air, reduced greenhouse gas emissions, and greater resilience against global energy shocks. As the transition to electric vehicles accelerates, cheap renewable power would make it easier for drivers to ditch gasoline for good. In places like California, where refinery closures and fuel price spikes threaten to disrupt the market, the case for switching to electric cars, buses, and trucks becomes even stronger. But let's not overlook the risks and roadblocks. Engineers caution that wind speeds near the ground are often lower and more variable than at high altitudes, potentially limiting the system's output. While Airloom is betting on advanced materials, clever aerodynamics, and smart controls to make up the difference, the proof will be in the pilot project. Regulatory red tape, shifting political winds, and local opposition can also slow the rollout of any new technology. A single high-profile failure could feed the narrative that renewables are unreliable, giving ammunition to those who want to cling to coal, oil, or nuclear power. There are also questions about maintenance and longevity. Can a system with more moving parts, exposed to the elements at ground level, hold up over 20 or 30 years, the typical lifetime of a wind farm? How easily can technicians repair or upgrade the wings, tracks, and support structures? Airloom argues that the lower height and modular design actually make repairs easier and safer, but this will need to be demonstrated in real-world conditions. Let's zoom out and consider the broader context. The United States Department of Energy recently warned of increasing risks to grid reliability, predicting that without substantial new investment, the country could face up to 100 times more blackouts by the year 2030. Traditional power plants, coal, oil, gas, and even nuclear, are expensive and slow to build, often taking a decade or more from planning to operation. In contrast, Airloom's approach promises to add clean capacity in a fraction of the time, helping to stabilize the grid and keep the lights on during periods of peak demand. Globally, the stakes are even higher. As countries race to meet climate targets set under the Paris Agreement, access to cheap, scalable renewables will determine who leads the clean energy transition. China has invested heavily in both wind and solar, aiming to dominate global supply chains. Europe, facing soaring energy prices after the war in Ukraine, is scrambling to expand its renewable fleet. Innovations like Airlooms could tip the balance, giving the United States a new edge in the global energy race. Of course, history teaches us to be cautious. The 1980s saw a wave of wind startups in California's Altamont Pass, many of which disappeared as quickly as they appeared. Designs that look good on paper often failed in the field. Investors lost millions, and public trust in wind energy suffered a setback that took decades to repair. Will Airloom break that pattern or repeat it? What makes today different is the convergence of advanced materials, digital controls, and a much larger, more sophisticated energy market. Airloom's team includes veterans from Google X, SpaceX, and leading aerospace firms, bringing together expertise in robotics, automation, and scalable manufacturing. Their design is not just a bold bet on physics. It is also a bet on the power of modern engineering, big data, and global supply chains. And here's a secret you might not hear elsewhere. The inspiration for Airloom's radical design came not from a laboratory or a boardroom, but from the founder Robert Lumley's passion for kiteboarding. Imagine the thrill of harnessing the wind to ride the waves, and then translating that dynamic, efficient use of airflow into a new kind of wind machine. Sometimes, the next revolution in energy begins not with a government grant, but with a flash of creativity on the water. So what happens next? If the Wyoming pilot proves a triumph, Airloom's wings on a track concept could become the new blueprint for wind energy. We might see wind farms popping up in places previously considered impossible. Mountain valleys, urban fringes, coastal zones, even in regions where traditional turbines are banned. With installation times measured in months rather than years, the speed and scale could rival, or even surpass, that of the solar industry, which has already transformed how America generates power. If the technology works as promised, the consequences could be breathtaking. Manufacturing jobs would spring up to build thousands of modular components. Communities could reclaim control over their energy destinies, generating clean power locally rather than relying on distant, centralized plants. The cost of electricity could plummet, making energy poverty a thing of the past. And as grids become greener, everything from electric cars to smart homes would become more affordable and accessible. But if the pilot stumbles, if the numbers do not add up, or the system fails under Wyoming's punishing winds, the dream could unravel. Investors might pull back, regulators could get cold feet, and public confidence in radical new designs could take another hit. Yet, even in failure, there are lessons to be learned. Every attempt, even the ones that crash and burn, paves the way for the next breakthrough. As history shows, progress in energy is rarely a straight line. Success is built on a mountain of setbacks. What does this mean for you, right now, as you watch this video? First, it is a powerful signal that the energy landscape is changing faster than ever before. New ideas are challenging old assumptions. Whether you are a homeowner thinking about rooftop solar, a business leader looking for ways to shrink your carbon footprint, or simply a curious observer of world events, the pace of innovation means more choices and more opportunities are on the horizon. If Airloom's approach takes off, you could see new options in your community for clean, reliable, and affordable power. Rural towns, islands, and even city neighborhoods that once seemed out of reach for renewables might soon host their own wind farms. The cost savings could ripple through everything from grocery bills to public transportation. And as energy becomes more local and resilient, the risk of supply chain disruptions, like those seen during the pandemic or after natural disasters, would shrink. Even if you are not planning to build your own wind farm, these changes will affect your life. As the cost of clean energy drops, expect to see more affordable electricity bills, fewer price spikes, and a stronger case for switching to electric vehicles, heat pumps, or induction stoves. For investors, keeping an eye on breakthrough technologies like Airlooms could reveal new opportunities in green infrastructure, manufacturing, or smart grid management. For students and job seekers, the rise of next-generation renewables could open up careers in engineering, construction, data analysis, and more. As for the broader economy, cheaper and more flexible energy unlocks innovation across sectors. Factories could run on ultra-low-cost power, boosting competitiveness. Data centers, the backbone of our digital world, could expand sustainably. Electric vehicle charging networks could grow without straining the grid. Even agriculture could benefit, with farmers powering irrigation, refrigeration, or processing equipment with on-site renewables. So, can Airloom's unusual turbines really transform energy generation? The answer is, the potential is enormous, but the final verdict will depend on what happens next in Wyoming. If the pilot succeeds, and the numbers hold up under real-world conditions, we could witness a transformation as profound as the dawn of solar panels or the rise of the internet. If not, the lessons learned will still shape the next wave of innovation, reminding us that true breakthroughs rarely follow the expected path. And as a final thought, remember, every great leap in technology is built on a foundation of bold ideas, relentless experimentation, and a willingness to challenge the status quo. The future of energy will not be decided by inertia, but by the courage to try.